In the previous lesson, we were looking at the use of the Venn diagram to solve probability problems. But some questions will actually require what we call contingency tables, just like there are questions that will be easy to answer using tree diagrams. We will look at tree diagrams later in the next lesson. Let's look at the two-way contingency table. This table looks something like this. The question says, or the situation in the question says, a survey was conducted among 100 boys. So there are 100 boys in this survey and 60 girls. That makes a total of 160 learners for this particular survey. This survey was conducted to determine how many of them watched TV in the period during which examinations were written. The responses are recorded on the table. Right. There is a row for the males and another row for the females. Then we have a column for those that watched TV, and there is another column for those that did not watch TV. So we call it two-way because we have rows and columns there, and we can actually enter the information and summarize the information about this particular situation in that table. Question 1 says we need to work out the values of A and B. Now we know already that there are 100 boys in the survey, which means we can put 100 in that cell there. And we are told there are 60 girls, so we know that this is 60. And now you can work out the missing numbers, like what is A? There are two ways to find A. If 80 boys watched TV and there is a total of 100 boys, then A there represents the number of boys who did not watch TV. And so you can subtract that and get A is equal to 20. You will notice you can get the same 20 if you take the total number of learners who did not watch television, that is 32, and subtract the number of females who did not watch, which is 12. That will still give you 20 because A is the number of boys who did not watch television. Right, then for B is the total for the number of learners that watched TV. So we need to add 80 plus 48 to get B. And so we will get B is equal to 128. Once again, the 128 could be found by subtracting 32 from 160. Okay, so A is equal to 20. You need to write it down somewhere. And B is equal to 128. The second question says, are the events being a male and did not watch TV during exams mutually exclusive? So we are given two events. Being a male, let's assume that M means being a male. And I'll call D, the other set did not watch television. So the question is, do you think M and D are mutually exclusive? So now you need to remember the meaning of mutually exclusive events. There are two definitions maybe for mutually exclusive events. The first one is that if they're mutually exclusive, then it means the two events, M and D, actually do not intersect, which means the intersection of M and D has a probability of 0. So if these two sets are mutually exclusive, then the probability of M and D should be equal to 0. This is the first definition that you can use. The second definition you can use is if the two are mutually exclusive, then the probability of M or D must be equal to the probability of M plus the probability of D. Okay, so let's answer this question. I will use the first one because I think this is a straightforward question. I would actually give 2 marks for this kind of question. So are the events being male? In other words, do you think M and D are mutually exclusive? Right, think about that. But I think no, they are not mutually exclusive. You don't have to start with no. You may actually need to start by working out using any one of these 2 definitions here. Work it out, then conclude that it's no. Okay, but I know in this case because I did work this one out earlier on. And the reason why, because it says give a reason, give a reason. The reason why I say no is because if I take the probability of M and D, if I work out the probability of M and D, the probability that one person chosen at random is male and did not watch television. Obviously, we are talking about those 20 there. There is 20 learners that are male and did not watch television. So the probability is 20 out of the total number of learners in the whole group, which is 160. So clearly 20 over 160 is not equal to 0. That is why I conclude that these 2 events are not mutually exclusive. Here is 3.1. If a learner who took part in this survey is chosen at random, what is the probability that the learner watched TV in the period during which the examinations were written? So we're looking for the probability that one learner that is picked at random actually watched television. Right, how many people watched TV? Clearly 128 out of 160. You can simplify that answer. I think it will give you 4 over 5. You can write it as 0.8 or as 80%, or just leave it as 4 over 5. Part 2 of that same question says, a learner who took part in this survey is chosen at random. What is the probability that the learner is not a male? So this learner is not a male and did not watch TV. So you need to take note. It says and. So the learner is not a male and did not watch TV. Right, so it's probability that the person chosen is not male, so it's not male, and did not watch TV. So the idea is still the same. If you use M and W for the sets, we are actually looking for the probability of not M and not W, just like we did earlier on. Okay, so this is the probability that somebody picked at random is not male and this person did not watch television. So go to your contingency table. How many people there are not male who did not watch TV? That should be female, because obviously in this case, if they're not male, it means they're female. So we have 12 people there that are not male, and those 12 people did not watch TV. So our answer should be 12 over 160. Simplify that, it will give you 3 over 40. All right. The last question says, are the events gender and watched TV? Okay, this is another event, watched TV. Are these 2 events independent? Right, remember when we talk about gender, we mean either male or female. So do you think watching TV depends on the gender, you can actually answer this question from everyday life, but we are looking for a statistical conclusion, which means we have to carry out some tests here. So gender means male or female, and we are checking whether these two are, whether gender and watched TV are two independent events. I want to pick male. I could have picked female. I'll pick female later on and show you that the answer is the same. So I want to pick for my gender, I want to pick a male. So I'm comparing two sets. M for male. Right, then watched TV, I'll put it as W, which means this watched TV. This is because I don't want to write a lot of things. Now, to test for independence, we need to check whether the probability of M and W is the same as the probability of M multiplied by the probability of W. So that is what we are checking. So let's take the left-hand side. The probability of M and W. That means the probability that one person chosen at random is a male and the person watched TV. So how many males watched TV from the survey? Clearly that is 80 there. So this will be 80 divided by 160, which simplifies to 0.5. All right? So the left-hand side is giving us 0.5. Now we need to check for the probability of M multiplied by the probability of W. Probability of M means probability that one person picked at random is a male. How many males are there altogether? We have a total of 100 males out of 160. And that is multiplied by the probability that a person picked at random watched TV. How many people did watch television? There is 128 people that watched out of a total of 160. If you simplify 100 over 160 multiplied by 120 over 160, you can do that. You will notice that you also get 0.5. So what is the conclusion? So clearly, the conclusion is that the probability of M and W is the same as the probability of M multiplied by the probability of W, which means these two are independent. And I think it makes sense because watching television should not really depend on whether you are a boy or a girl. All right. Now, I used male to answer this. You could have chosen female, you will get the same answer. So if you choose female, for instance, let me see if I can squeeze it here. If you choose female, then we are looking for the probability that somebody is female and they watched TV, and we're comparing that one to probability that somebody is female multiplied by the probability that somebody watched TV. Now, if you look at the table, how many females are there that watched TV? There is 48. So this gives us 48 over 160. Now 48 over 160 will give you 3 over 10. If you simplify that, you get 30%, 3 over 10. Then the second part, probability that somebody is female. How many females are there? We are told there are 60 females out of 160. Multiply that by the probability that a person chosen watched TV. That will be 128. 128 over 160. If you multiply these two, once again, you will get the same answer, 3 over 10. And so because these are equal, we conclude that the events are independent.